This question is from GATE 2021 Mechanical Engineering paper, set 1, question number 40. A 200 mm white plate having a thickness of 20 mm is fed through a rolling mill with 2 rolls. The radius of each roll is 300 mm. The plate thickness is to be reduced to 18 mm in one pass using a roll speed of 50 rpm. The strength coefficient K of the work material flow curve is 300 megapascal and the strain hardening exponent N is 0.2. The coefficient of friction between the rolls and the plate is 0.1. If the friction is sufficient to permit the rolling operation, then the roll force will be dash kilonewton. Let's find out. We'll enlist the given things. Width of the plate B is 200 mm. The thicknesses are given. So initial thickness was 20 mm and the final thickness is given to be 18 mm. Changing thickness is nothing but 20 minus 18, which is 2 mm. Other things given, coefficient of friction between roll and plates is given as 0.1. The material strength coefficient K is 300 megapascal. Strain hardening exponent is given N as 0.2. RPM for the roll is given 50 RPM. We need to find out the roll force. Now roll force will be nothing but the average flow stress into the projected area, which can be written as, for average flow stress, the symbol is sigma F into the projected area will be the projected length capital L into the width of the plate small b. So we need to find out sigma F and L. B is already known to us. To find sigma F, that is average flow stress, we have a standard formula that you need to remember, which is given as K into epsilon F to the power N divided by 1 plus N, where epsilon F is the true strain, which can be written as natural log of final thickness upon initial thickness, which is equal to ln 18 by 20. This when calculated gives us minus 0.1054. Strain has no unit, it's a pure number. Here the negative sign is just indicating that this strain is compressive in nature. So it's the indicative of the nature of the strain. We don't have to take it in calculations. Next thing we need to find is L, projected length. Projected length L is given as under root of roll radius R into delta H. Both these things are already mentioned. We have under root of roll radius is 300 into delta H is 2. So we have root 600. This is 24.495. Let's put both of these values and find out the roll force. So sigma F we have to find out yet by putting epsilon F in this formula. So average flow stress sigma F is equal to 300 MPa into 0.1054 to the power N, which is 0.2 divided by 1 plus 0.2 is 1. This when calculated gives us sigma F value as 159.395 megapascal, and megapascal is equivalent to Newton per millimeter square. So we don't have to convert the unit of L, which is nothing but millimeter. Now roll force will therefore be equal to 159.395 into projected length is 24.495 into width is 200 millimeters. So this gives answer for roll force as 780,873 Newton. But dividing it with 1000 in order to get it in kilonewton, we have 780.873 kilonewton. Roll force, we can write it as FR, approximately equal to 781 kilonewton. Let's go back and put this answer. So rounded off to nearest integer, we get the value of roll force as 781 kilonewton. To learn more about rolling, you can refer to the NPTEL video Metal Working Processes Rolling. It's from the course Fundamentals of Manufacturing Processes. The course is taught by Dr. D.K. Dwivedi. He is from Mechanical and Industrial Engineering of IIT Roorkee. I hope this solution helps you clear your doubt. Thank you.